to find the shear strength. So what we have done is I have shown some veins. So this is the vein, okay, and top it looks like this, okay, and what we are doing is we are applying the torque, okay. So how to find the torque T? Torque T is equal to T1 plus T2. T1 is you can take it as a side resisting torque, okay. Torque nothing but the moment, okay, and the T2 can be taken as the top and bottom, this top and the bottom, okay. So here uh, if you take these sides, okay, these blades, so resisting torque would be this around this periphery only, I mean, so that's the reason I'm assuming S is the shear strength, then pi dh, okay, then pi dh, where it is acting, this is the load, or you can say force, okay. What I'm doing here, S is the shear strength, it is a kPa, kilonewton per meter square, you can say, suppose. Then what you have to do is to get the moment here, sides, right? If you, I hope you are visualizing it, just I'm focusing on side, so side resistance would be pi d h, whole length, whole length, okay, pi d h, and where it is acting, d by 2, okay, from the here it is acting d by 2, okay, that's what it is given T1. Here what is T2 here, top and bottom would be whole circle is involved here, okay, because these blades are like this, okay. So top and the bottom, these blades are, so whatever we have soil, whole soil would be involved, that means it is just circle, full of a disc, we call it as a disc, right. Here just a periphery, okay, here periphery, all around periphery, okay, would be T1, and top and bottom here, for second case T2 is top and bottom, and bottom, whole soil is involved from here to here, everything like a disc, okay. That's what it is given, 2 pi r, like a, let us take a small ring here, okay. Then shear strength S multiplied by the 2 pi r into dr, okay, where it is acting at a distance r, suppose. Then what you have to do is from 0 to d by 2, okay, and it is on both the side, that's why it is given 2, okay, both the side, top and the bottom, it whole circle is involved. Anyway, you will understand once, if you are not following also, no problem, once you sit and open your book, you will understand. So both the top and bottom is like a disc, okay. So 2 pi r multiplied by the dr, okay, and at what distance, at a distance r, is a moment, torque is nothing but the moment, okay. Then what we have to integrate everything, 0 to d by 2, so that whole circle will come to the picture, okay. Then why we have to multiply 2, because if you are penetrating only half, then no need of multiplying these two, only one, because I am taking both the side. So last class we have seen that guy has penetrated or inserted that blade half, only half, that means at the bottom only we have to, then no need to take these two, understand. So that's what the then what we are doing here, finally shear strength we are getting, torque will be knowing, okay. So by using this formula we can get the shear strength, okay. In the field also directly we can get the shear strength. Now what we'll do is we'll with that we are okay with this chapter, we will focus on this consolidation now. It's again the very important topic, consolidation, okay. So we have done with the shear strength, and again I have repeated what we have covered in the shear strength. So shear strength we have covered mainly uh, the Mohr circle and the triaxial direct shear test. In the triaxial we have different tests, and unconfined compressive strength where sigma 3 is 0. Again we have covered this wind shear test and some parameters what we are going to find out. You go through some problems by using yesterday we have seen that we can draw the Mohr circle, okay, and then you draw the tangent and find the C5, okay. It's very simple only, okay. So now consolidation, again this is a new topic, and this is also very important topic, okay. And in the last class we have seen something about the liquefaction, okay. Liquefaction, when the effective stress becomes 0, that liquefaction happens in the cohesionless soil only, sandy soil, fine sand only, okay, loose fine sand, because of the water, because of the earthquake, right? So pore pressure becomes dynamic and becomes equal to the effective stress, okay. Then what happens? Soil loses whole strength and our building is going to sink, building, okay. And previously, if you recall, in effective stress we have seen the quicksand conditions. Okay, boiling sand condition also we have seen that, in that case, when the water is flowing from the bottom to top, okay, again what is happening? Effective stress is reducing, and what is happening is sand become, it's like a boil. That means if you keep your leg, okay, you will sink. So these quicksand conditions, liquefaction and so on will happen in the cohesionless soil only. That you must remember. Okay, they will ask in some interview and all. Now coming to the consolidation, uh, so what I have told while explaining about the compaction, okay, what is the difference between compaction and the consolidation? In the compaction, we are expulsing the air from the soil. That means because of dynamic load, or because of the load, we are compacting, or a roller, we are compacting the soil and we are expulsing the, removing the air, and we are making the soil dense. In this case of consolidation, uh, consolidation generally happens in the saturated soil, that is fully saturated clay soil. Okay, here we are, what we are doing is, this is the phenomena of expulsing the, removing the water from the soil when the soil is saturated conditions. Okay, and here load is not dynamic, or what do you say, uh, load is not dynamic. Okay, load always would be static and long term here. Their load can be short term in compaction, whether you use roller or maybe tamping. Okay, we use static load, or dynamic load there, but with a lesser duration. Here, when I'm talking about the consolidation, consolidation means expulsion of the water from the soil. Because of that, when it will expel, slowly it will expel, because clay soil will have low permeability. So slowly expulsion of water takes place. Because of that, settling takes place. Because of that, settling takes place, and this settling is very important for us. Okay, we have to study this settling. So we do some consolidation test for soil also in our laboratory also. Okay, so so mainly this phenomena is to find out the settlement because of the expulsion of the water from the soil, not air. Okay, the soil is fully saturated here. The volume of void is fully filled with the water. Okay, so here, so why we have to study this consolidation? Have you heard about this leaning tower of Pisa? Please
Yes.
respond. So why it is leaning? Why it is leaning? This is all because of consolidation only. Okay. So this is all because of consolidation. Okay. Why it is leaning? Because it is all because of consolidation. What is happening here is, the soil is consolidated here. So because of that, this is just leaning. So this is the phenomena. Again, they have done a lot of studies have been done here. Okay, so below this particular tower, the soil is a clay soil, and slowly, what is happening? The soil is settling down. Okay, so slowly, soil is settling down. Because of this one, what is happening is, so they have done some modification also. Okay, people are there. They have explained. Sometimes they will come to some conference and they will explain us what are the measures they have taken to keep it. So it is a very tourist attract. Okay, if it is not leaning, then it would have not been a attractive tourist spot. Okay, so because of that, so what they have done is, while construction, at the time of construction, they have not studied the soil behavior. They have not improved the ground. Okay, so fully clay soil was there. So that time they have not worried much. Then what happened is slowly the water expelled and the uh, settlement took place. Because of that, one side it started settling down. Okay, likewise, I can give hundreds of examples. Okay, people don't spend money for construction. Okay, for studying the soil behavior or finding the bearing capacity and so on. So simply they will focus on the structures. Okay, so many blunders people have done it in the in previous you can say construction. So what they will do is without understanding the ground, which soil it is. So simply they design a beautiful fauna, beautiful structures, and simply they construct on this clay soil. So because of that, what happens? No, because clay soil will try to swell and shrink. Then what happens? Slowly, settlement takes place, and you could observe some cracks in the buildings. So this is all about consolidation, that is settlement. Okay, so we can measure how much settlement the soil undergoes. Okay, so here if you here that's what it is given here. Okay, introduction is given, like expulsion of water in the voids, expulsion of the air, and so on. Okay, so we are talking about this expulsion of water from the voids. So that's what it is given in introduction. Okay, and in the next headlines it is given like initial, primary, and secondary consolidation. Consolidation will have three stages. Okay, initial consolidation means when the load is applied to partially saturated soil or saturated, decrease in volume occurs due to the expulsion of the uh, air in the voids little bit. Okay, so that is called initial consolidation. So consolidation takes place in three phases. Okay, initial consolidation, primary consolidation, and the secondary consolidation. Okay, initial consolidation is just when you apply a load. Okay, there may be some air. Okay, that if it is a partially saturated soil, so this expulsion of air will take place, and because of that a small decrease in the volume also occurs. Okay, due to the compression of the little solid particles also. Okay, uh, so the reduction in the volume of the soil just after the application of the load is known as the initial consolidation. Okay, next coming to the primary consolidation. Okay, after initial consolidation, further reduction in volume occurs due to the expulsion of the water from the void. That is very important. Okay, so whenever I am talking about the consolidation, I am talking about the primary consolidation only. This is very small. The initial consolidation is very small. Even secondary consolidation also very small. So wherever you could see the major change in the volume, this is all because of the primary consolidation. If I'm talking about the consolidation, if I'm telling you because of the consolidation, I mean to say that this is because of the primary consolidation. Initial consolidation, the reduction in the volume is very small. Even secondary consolidation also, reduction will continues very slow rate. Okay, even after the water expulsion takes place. Okay, very slow, and there would be some readjustment of the particles, small friction from the particle, or breakage of the particles, and so on. This secondary consolidation takes place very slow. Understand? But primary consolidation takes place wholly because of the expulsion of the water, and the change in the volume also very drastic and very huge. Understand? So it takes in three phases. One is initial consolidation, second is primary consolidation, third is secondary consolidation. These are very small. Initial and the secondary consolidations are very small, but primary consolidation is very huge. Okay, for reduction volume takes place because of the expulsion of the water. Okay, next, now what this Terjagi has done is he has uh, given a spring analogy for primary consolidation. What is happening is, are you able to see these pictures? Please respond whether you are following or
Yes,
not.
sir. It's visible.
Yeah. So what he has done is he has used some spring analog. Okay, actually how the consolidation takes place in the soil. As I said, consolidation takes place in the clay soil only. Okay, because because in sandy soil, right, because it is a permeability is very high, there is no possibility of holding up the water. Okay, whenever you apply load, immediately the water dissipates. Okay, so it's not a long term process. Okay, in sandy soil and so on. There in sandy soil, liquefaction takes place because of the pore pressure and so on, because of the dynamics, liquefaction takes place, as we have seen in the shake table, how the buildings are a small model building is sinking. Okay, here in the case of consolidation, generally it takes place in the clay soil. Okay, because it is a slow process. It takes 100 years. I won't say 100 years. It takes few years, 1 year, 2 year, 3 year, 4 years. Okay, so that's the reason I have seen that some places in the Amravati were newly built capital. Okay, I think it is shifted now. Okay, in Andhra. So that full whatever you see, it is on the bank of the river. Okay, so they have constructed some building. So my friends were telling that those buildings were sinking, and there are so many cracks developed because it is fully on the clay soil they have constructed. Okay, without using the pile foundations, some buildings have been constructed. So because of that, they have not improved the ground. So what is happening? Consolidation is taking place, and slowly buildings is settles down slowly, and it may be like leaning tower of Pisa, right? So in many places, even London also. Okay, London and many places, some high-rise buildings have been constructed near the bank of the Thames River. Okay, and many countries, right, are there. You can see Hong Kong also on a sharp, you can say, on a sloping ground. Okay, with the clay soil, but they have taken measures. Okay, so they have used pile foundations and other techniques they have used, and they have improved the ground, and they have done their construction high rise buildings. Okay, so likewise we have to take the even major cities in the world, you could say, whether it may be New York. Okay, you can say like Hong Kong or even a Sydney. Okay, many cities you could see on the bank of the river, or a bank of the, or you can say on the coastal of a sea coastal. Okay, so in so these soils are not very good. Okay, in the coastal areas, soil would be fully of clay soil. uh, so because people want to have very good views of this ocean, so that's the reason the cities have been developed there. Okay, so many city in the world you could see. Okay, on the bank of the river, or a bank of the maybe in a coastal region. So there we have to take very good measures. Okay, when you are constructing so much high rise building, so we have to go much deeper. We have to use the pile foundations. Okay, for or whether or we have to improve the soil, then only we have to go for a construction. Otherwise what happens, the same thing, soil will try to slowly in 100 years settles down, and the structures collapse sometimes, or give some warning. It could develop some cracks. Okay, so life ultimately the life of the structure would be less. So always suggested that always we should construct in a rocky area, or is gravelly sandy, where the gravelly or sandy soils are there. Okay, so what he has done is Terjagi. What he has done is here on some in some cylinder with water and a spring. Okay, here what you have, how you have to imagine this consolidation. Okay, first wall, close this wall and apply load, then all load is taken by the water, is it not? So, because water is incompressible, so all load is taken, one load taken by the water. So initially the same thing happens to the even our soil also. When you start constructing a building initially, okay, so all water would be taken by the water, load would be taken by the water. Then you open a wall. What is happening is, now what happens? Slowly water will dissipate, go out, expulsion of water takes place. Then slowly the load would be taken by the spring here, right? There in the soil grains will takes place, takes the load. Understand? Here what I am doing is soil I am considered as a spring. Okay, soil as a spring. So what is happening when wall is open? What is happening? then water will try to, because water is incompressible, will try to go out slowly. Then slowly, all the load would be taken by the spring. Then finally, whole load would be taken by spring. That is secondary consolidation. Understand? So initial consolidation, then expulsion of water takes place. Then slowly, all the load taken by the secondary in the secondary consolidation. Okay, and slowly, the water will go out. Initially, the rapid expulsion of water takes place. Then it slows down. Then whole load will be taken by the soil. There, the effective stress increases. We know the definition of effective stress, right? Effective stress is total stress minus pore water pressure. When you're deducting pore water pressure, more you are deducting, then what is happening is effective stress is increasing. Understand? When the pore water pressure is increasing, effective stress is decreasing. When the pore water pressure from the soil is reducing, then effective stress is increasing. That's what we need it. We need the effective stress to be increased, okay, for our foundation, for our soil. Understand? So that's how it is given. Okay, just go through it. That's what it is explained here. Then what is happening is behavior of a saturated soil under pressure. What happens, right? Suppose that's what it is explained here. Okay, when you read it, the same thing. What is happening is the load is taken by here the pore water pressure, then it is expulsion, then it is equal to the effective stress is equal to total stress. Okay, and then if you plot a graph, okay, with the time, so what will happen to void ratio? Initial void ratio, if you have initial void ratio here at the time 0, okay, then when the time is increasing, what is happening to void ratio? It is slowly reducing. Is it not? Void ratio is slowly reducing, and it will attain some values. Okay, that is called critical void ratio. We have seen the final void ratio, right? Beyond that, it's very difficult to reduce unless you do something. Okay, so what is happening is effective with the time, the void ratio is going to keep on reducing. Understand? So that's what it is given. What about this graph consolidation test? So we do anyway. I will show some video to you, consolidation test. Okay, what we are doing here in the consolidation is, let me check some consolidation test.
This soil sample we can implement with the two types. One is the remolded soil.
Audible? Please respond.
Yes, sir.
Yeah. So really, it is very good that our online teaching, right? So that I can show you some videos also. Okay. So only thing is you have to develop concept. Okay. So now, so this is the consolidation test. Okay. Will be in the laboratory. We do have in
This soil
NIT.
sample we can implement with the two types. One is the remolded soil samples or undisturbed soil samples. The remolded soil samples, desired water content has to be added in it, and then it has to be compacted with the 3 layers. The soil passing through 425 micron has to be implemented in it. If I am working on the undisturbed soil samples, then we have to implement, go to the site and then take out the undisturbed soil samples. Now at present, I have taken the undisturbed soil sample, I have trimmed up with the upper and bottom surface. Now, this base of the consolidation ring has the number of the grid patterns. So here, this is the channel where the water passes and drains out quickly. Now, this is your upper layer of the consolidation cell. Firstly, we have to put up stones. This porous stones we have to implement firstly with the bottom plate and then the filter paper. Nextly, the soil sample. Okay, and then the consolidation ring. Consolidation ring is smooth to reduce the friction. and it has a diameter of 6 centimeters. Also, cell with a diameter of 10 centimeter are also available. The thickness of the cell sample is of 2 centimeters. The diameter and the thickness ratio should be around minimum 3. Later on, after the soil sample implementation, the filter paper has to be assembled. After this assembly, the porous stone has to be implemented. Okay. Now to interact this assembly completely, then the upper ring has to be implemented. It has to be tightened with the help of the screws. It has to be tightened completely. This is your perforated pressure pad. Just I have to place on the top. After tightening up the screws, this assembly is completely intact. There are two types of consolidation cells. One is the floating free ring cells. Another will be calling it as fixed ring cells. This is completely fixed ring cell. Now the floating ring is on the both top and bottom of the porous stones are free to move and loading is done. Here with this fixed type, only the top porous stone can be moved. This is the difference between the floating and a fixed one. This is completely a fixed one. Okay. Now we'll be moving for the loading device. Now the loading is applied by the suspending the weights by the lever arm. You can see over the lever arm. Whenever you start the experimentation, this lever arm should be with the horizontal. One to need. Okay. Now the sample to be saturated, the loading device consists of a small reservoir connected to the cell with a plastic pipe. Okay. This is your reservoir, like a small reservoir, where my sample has to be saturated completely, first of all. Okay. Throughout the experimentation, it has to be saturated. The lever arm should be with respect to horizontal. After complete assembly, you have to go for the fixing up the dial gauge. This dial gauge gives us the deformation. After connecting to the reservoir, the sample, we have to ensure the soil sample has completely saturated. Now leave the soil sample to be saturated. The seating load has to be applied to the lever arm. Just I am applying the seating load as per the IS code 2720 part 15 as 0.05 kg per centimeter square. This is my seating load now. Now after applying the seating load, the setup has to be left 24 hours. 0.1 kg per centimeter square. Load has implemented. Now I'll be starting down to take the deformation readings. My deformation reading firstly is of 20 mm. With respect to time, nothing but 25 seconds. The reading is 19.99. Hence, like this, we have to take down the readings, nothing but the deformation with respect to time. I'll be ending up. After completing this for 1440 minutes, I will be switching on to another load increment. Implementing 0.2 kg per centimeter square of load. Always look at the incremental load should be double with respect to the previous loading. Now I'll be starting down to take the readings with respect to my time again. Once I implement the load of 0.2 kg per centimeter square with respect to time, once I ended up with the deformation reading as 19.95. Then after ending up with this 0.2 kg per centimeter square, Again, I'll be doubling my weight. Okay, the loading is 0.5 kg per centimeter square. Again, just I'll be implementing 0.5 kg per centimeter square. Okay. Again, the same procedure has to be cultivated with respect to the time I have to take down the readings again, the deformations. Okay, like this, we have to go for 0.1, 0.2, 0.5, 1, 2, 4, 8. All the readings has to be captured. Now we have done with the 8 kg per centimeter square of the loading.
Hope you understood. Okay. So this is all about the consolidation. Then what we'll do is we'll plot a graph like with different stresses, and the final void we will talk, and so this is what it is given for stones and the all other things. Okay. So maybe next class we'll you read up to here. Maybe next class what are the parameter at various stages we can find out, we can see. Okay. So at least we see that how we can conduct the consolidation in the laboratory and what is consolidation and so on. Okay. So should I stop today? So consolidation is not included for your exams. Okay. So what we have finished, hope you have purchased some new book of Aurora. So how many chapters we have finished, if you recall? So introduction over basics, particle size distribution, plastic characteristic classification, sixth, okay, permeability, CPS analysis, effective stress due to applied load. This is a consolidation. Okay. After that, shear strength we have done, and compaction also we have done. I think these 15, 16s are not there. Okay. So these are important things also. You can maybe it is included in master. Okay, MTech. So if you do MTech in geotechnical engineering, so you will study the soil stabilization and drainage and dewater. Okay, which I have done in masters in geotech. Okay. So foundation engineering next semester is going to be your site investigation and other things. Okay, foundation engineering this next semester from 17. So these two you leave it. This we have covered and this we have covered. Now this is the last chapter. Okay. So up to here you have to study up to 14th for this semester. Okay. So we are started the consolidation, and in April we'll finish up this consolidation. Okay. Rest of the things are very easy. Only thing is you have to spend little time and read. One reading is enough. Okay. For our civil engineering subjects, these subjects are not very difficult actually. One reading will be enough. Only thing is you have to spend time and read it and understand that particular subject, whether it may be structures or a building material or construction or a surveying, any or a strength of material. One reading generally will be enough. So it is not the difficult branch